Okay, can everyone hear me? Good. Let's get started. Okay, so welcome to CSE 410 software security class. If you want to be a hacker or you want to exploit software, especially binary software vulnerabilities, you are at the right place. My name is Zemin Zhao. I'm an assistant professor at the Computer Science and Engineering Department. So before we get started, I want to say something. Today is actually Chinese and lunar calendar New Year. So happy New Year to everyone. This is a year of tiger. So okay, I want you to know that I am recording everything, the lectures, and I will post them on YouTube. If you, for some reason, you cannot be here in person, you can also join our room session, but I expect you guys to be here in person. But you know, this is still during pandemic, a lot of things can happen. I hope you have a pen and a paper in front of you, or also so you can take notes and also join something for some of the software hacking we're doing. I want you to draw things for you to better understand what's going on. Also, maybe from next week, I hope everyone bring a laptop. So this semester, I'm trying something new. My team developed a cloud-based platform for this class. So technically, you only need a Chromebook to remotely access the system to play the CTF, finish the homework, everything, but still you need some, at least you need a Chromebook. If you haven't already, please join this Slack channel. I asked the TA to send you an invitation last week. If someone joined very recently, probably don't have the link. Otherwise, everyone else should have the link. But some of you are already on that Slack channel, right? Okay. So everything about this class will be on this GitHub link. So this is basically my personal website. And I'll put everything here except the exams, the homework, the lecture notes, the video of the recording of the lecture, everything here. Also other reading materials, but the exam, I do not put them online. So during the class, if you have any questions, please feel free to interrupt me. By the way, everyone should wear a face mask. Hopefully, this will be our last semester to wear a face mask. But for now, this is still necessary. A little bit about myself. My name is Zemin Zhao. I am an assistant professor at CSE. I direct my own research lab. I call it Cyberspace Security and Forensics Lab, or CAPTA Lab. I call it CAPTA Lab because I lived in Arizona for many years, and I just like Arizona. So as you can tell from the name, my lab works on all kinds of security, privacy, and forensics problems. Right now, we are mainly focusing on several directions, which I will discuss in a minute. You can find more information about my lab, about my research at those websites. The best way to reach me during this semester is email, Slack. Usually I will reply to you in minutes when I see something on the Slack channel. You can also email me, but I actually prefer you to just ping on the public channel on Slack. So if you have any questions, other people can also say your questions. That will generate more discussion. That's better than email. So because of the pandemic, and also I have a toddler at home, so my daughter cannot be vaccinated. So this semester, my office hour will still be online. I already did the office hour online for a year, more than a year actually. And it's quite successful because we can share screen, you can share your screen, I can share my screen, and we can say, the coding, everything. It's quite easy. So my office hour is Wednesday, basically the hour before the class. Or if you have any other question you want to meet, just ping me on Slack, then we can schedule a meeting. We have a TA for this class. His name is Thomas. He's not here today, and his office hour is Friday. I think it's 3:30, not 3. Probably is a typo there. Maybe, let's just make it 3, whatever. Okay, so Thomas has been here for this class for last semester actually, and he did a very good job. He's my PhD student. He works on system security with me. So every week this semester, we will meet twice in this classroom, Monday, Wednesday, from 5 to 6:20. We will have a very interesting class. I personally, obviously, this is what I work on. This is where my passion is. And I've been offered this class twice at UB. A lot of people love this class very much. I got very good reviews for the last 2 years. But still, some people do not like this class and they cannot survive, and usually they quit in the first 2 weeks. So if you feel this class is not for you, it's just you can come back maybe next year, or you can get some background knowledge online somewhere. You don't have to take this class. This is not a required class at a CSE right now. I'm trying to change the class to a regular class, but it will take some time. So in this class, we will not only have lectures, we will also have a lot of demos in the class. For the hacking, we will have demos, and you will do all the hacking by yourself. So sometimes we will have in-class hands-on practices where you will hack some software I developed for you, designed for you, and also write some share code, something like that. That's why I ask you to bring your own laptop to this class. A little bit about my lab. We work on all kinds of cybersecurity issues. First, we work on embedded system and software security. The ARM Cortex-M, those very low-end microcontroller devices like your Fitbit, some like medical devices. Also, we work on Cortex-A. Those are the CPUs power your laptop. Not many laptops are using Cortex-A. Maybe most of your phones, your tablets, some of the laptop, some of the servers are using Cortex-A, but not many. We also work on FPGA, RISC-V, those architectures. But this class is mainly on x86 because most of the software classes are still on x86. But the principles, the techniques you are learning from this class can apply to other architectures. Our research is working on other architectures. I also work on securities in machine learning, deep learning, also security with machine learning, deep learning. I also work on autonomous driving security, formal verification of security protocols, blockchain security, and also the last one is related to this class is we also work on hacking and also CTF platforms. So in this class, like I said, you will use a platform we developed specific for this class. At the same time, we're developing another platform, and that platform will be public, open to everyone who is interested in hacking to play. And that platform will be a little bit different from the popular x86 platforms in the world right now. We are going to extend that to all kinds of architectures. You will be able to hack Cortex-M systems on our platform, RISC-V platform, RISC-V architectures on our platform. Also, I don't know how many of you play Roblox. No one? Too old to play that? So Roblox is a gaming platform for kids. My son is 6 years old, so he plays that. So I saw my son playing on Roblox. I realized Roblox is a place you can play all kinds of small video games, and also you can design your own video games and host it on Roblox. So I thought that's a very cool idea. So for our CTF platform, our goal is not only you can play all kinds of try to hack all kinds of challenges. We also want to have a challenge creation platform for you to develop all kinds of challenges and host on our system. So obviously you can see that I have a pretty big lab. I always look for students to do research with me, sometimes funded research, PhD students, some master students will be funded. For undergraduates, you can do independent study or volunteer work with me if you want. Some people has been, I have a lot of undergraduates who work with me before. Some of them have been very, very successful, very beneficial to their career. Okay, so this class is cross-listed as 410 and 510. So there are some undergraduates, also some graduate students here. I don't know if there is any PhD students this year. Any PhD students this year? No? Okay. So last semester, I had several PhD students. The TA already sent you the invitation to join our private Slack channel. And that's where you can ask all kinds of questions, discuss homework. This class is the same for undergraduates and graduates. You will have the same homework, same exam, the same grading policy. Okay, so this class is all about hacking binaries. At the end of this class, you will have a pretty good understanding of the theories, principles, techniques, tools used for binary software and system hacking, and also defense. We focus on binary code in this class, which means we will not discuss other software systems. For example, for web hacking, web security is a big class. It deserves its own class. And actually in our department, we do offer a web security class, but I'm not teaching that class. In this class, we mainly, like I said, we mainly use x86 and x86 34-bit version as examples in the class. So you will study in-depth binary reverse engineering, vulnerability classes, vulnerability analysis, how to exploit those vulnerabilities by writing exploits by yourself, byte by byte. Also, you will study some defensive solutions. Some of them has been deployed in real-world systems. So basically, you will understand how to crack and protect native software. One very important thing in this class is for you to be successful in this class, you need to get your hands dirty by hacking. So not only should you understand the theories, principles behind the vulnerabilities, more importantly, you need to actually exploit those vulnerabilities. I will show you step by step how do you exploit each vulnerability, and in the homework every week you are going to replicate that. In the exam, well, there will be some challenges we do not really cover. I will change those challenges a little bit here and there, and you are going to hack those challenges. And for the exam, it's the same. There will be new challenges, and you need to figure out how you can crack those challenges in 2-3 hours. That's a homework. So obviously, rote memorization of concepts is not the purpose of this class. I emphasize problem solving rather than proficiency in remembering those concepts. Okay, I think this is a better fit for the actual environment of your future work or scientific research. So the only way to learn in this class is just to hack, no shortcuts. Also, the homework, the exams for this class, they will all be open book. You can check the lecture notes in the exam. You can even Google in the exam. The only thing you cannot do is you cannot communicate with anyone in this class or outside class during the exam. So the challenges will be new, so you cannot find those answers online anyway, but you can find some hints online to help you solve that, but it's possible. Okay, so if you really want to be a system or software security researcher or work in this area, where this course is at. So basically, some of you took the system programming class, systems programming 220. That is a class teaches you how to use Linux APIs. How do you develop Linux programs, basically. Then there are operating system classes, compiler classes. They are all very helpful, but not required. The only required basic knowledge for this class, I would say, is programming in C. If you cannot program in C, you will for sure struggle in this class. You will not be able to understand many things in the class. If you do not have background in OS or compiler, I will try to cover those things in this class, try to make the class very self-contained. Okay, so this course is about learning binary bugs, vulnerabilities, and learn how to manually exploit them, which means you are going to write exploits byte by byte. So you fully understand how the vulnerability works, you fully understand how the exploits work, then you develop exploits to subvert a system. So you can say this is baby steps in hacking. So I also offer another class, advanced software security, but I do not offer that very often. And that class for now is 700, I believe, 700 or 600. So it's not available for undergraduates. I want all my classes to be available to both graduate and graduate, but sometimes the department doesn't want that. I'm still working on that. So in that class, advanced software security, we learn how we can automatically use tools or develop tools to discover vulnerabilities, and also exploit those vulnerabilities. And we talk about advanced defense techniques to defeat all kinds of vulnerabilities. In this class, we will cover some basic techniques. Most of them have been deployed. So in that class, we talk about state of art. So if you take those two classes, then you are ready to read some state-of-the-art papers. You can understand their systems. Then you are getting closer to research in this area. This class is a baby step. It's very necessary. So you can see that our education, no matter which area you are interested in, maybe you are in machine learning, you are in computer vision, you are in system, there's a huge gap between what we teach in school and where the state of art is. And a lot of classes cannot fill the gap right now. So my two classes are trying to bring you closer to the frontier. But still, if you finish those two classes, you want to do research in this area, you still need to read a lot of papers, you read a lot of code in software systems to get it. Okay, so this week, we will go through the class overview, logistics, before we dive into some background knowledge. You probably have picked up several pieces of background knowledge from other courses, or maybe you picked something up from your programming projects, hacking experience. But please bear with me, since I always want to make this class self-contained, so people with different backgrounds can survive this class. Having said that, I will cover most hardware and operating system knowledge you need for this class in this week. We will briefly talk about how compiler, linker, loaders, how do they work. We'll talk about x86, 32-bit version, and 64-bit version, their architecture, their instructions, Linux file permissions, what are setuid programs. A quick quiz here. How many of you know what are setuid programs already? No one? That's not possible. Come on. Really, no one? Okay, then you're going to have a very fun semester ahead. Okay. We'll talk about how the memory map of a Linux process looks like, important system calls, environment variables, and also we'll cover some basic reverse engineering techniques. This looks like quite intimidating, well, but like I said, I've been teaching this class for several years. So students love this class. Last semester, I think my overall evaluation was 4.8 for over more than 50 students. So I go extreme in depth to talk about all the details. So as long as you follow the class, you do the homework, you watch my video, everything should be fine. Okay, like I said, the only real prerequisite for this class is the C programming language. In this class, you will program in C, just a little bit. Most of the time, we're not doing any programming. Also, you will read a lot of C code. But the C code we have in the class, I designed for this class specifically. They show some vulnerabilities. They are very simple classes. They are very simple code to show vulnerabilities. But if you struggle in C, for sure you're struggling in this class. So if you feel you need to catch up with C programming, you can just find this book, the classic, the C programming language book. So this book is not only about the syntax of C, it's also about how to use the C standard library. I think you can find this book online. You definitely find this book online. It's like published back in 80s. If you want to learn C, this is a book to go for. All other classes I listed here, like I said, they're not really required. The skills you will learn in this class include reverse engineering, debugging. Some of you may have used the tools like OBJDump, IDA-Pro, Hydra, which was published by NSA several years ago, or other debug tools like GDB. Those are the tools we will use a lot in this class. I guess for most of you, you probably never heard of something like IDA-Pro or Hydra. We probably will not use them. I want to keep this class very simple. We are going to use simple tools, not advanced tools. I don't want you to use advanced tools who does all the job for you. Instead, we use simple tools so you can fully understand what's going on. The most important skill for you to survive in this class is the same skill you will use for any real-world job or real-world research, which is self-learning and Google. When you find something you don't know, there is an instruction you don't know what that is. You do not always just ask me, hey, or the TA, what that instruction is. It's just simpler to Google and find out what it is. Every week, I will give you a lot of reading assignments to help you catch up as well. Okay, the topics. So we will discuss the following topics in the class. You will learn many vulnerability types, how to develop exploits for those vulnerabilities, and some of the state-of-the-art research on those topics. So here I highlight two words. One is vulnerability, one is exploit. I've been using those two words a lot in the last 25 minutes. So there are different things. Vulnerability is a weakness in a software system. And an exploit is an attack that leverages some kind of vulnerability. So the vulnerability is already there in the software, but we need to find them out. Then after we find them out, we want to somehow utilize that to subvert the system so the system can work for us. In particular, what you will learn. The topic include stack-based buffer overflow, how to defend against that, how to develop a simple shellcode, format string vulnerability, heap-based buffer overflow, return-oriented programming, integer overflow. Usually in the last 2 years, I also cover some micro-architecture vulnerabilities like cache side channel attack. So let's see if we have enough time to cover that this semester. So any of you hear anything here? I hope this is not totally new to every of you. You hear something? Yeah. Maybe just you pick up from news, something like that. Okay. Yeah, sure. I mean, that's why you're here, right? Cool. So there are several papers I built this class around. For example, one of the paper published in IEEE Security and Privacy, I call it SMP, 2013. It's called Eternal War in Memory. SOK means systemization of knowledge. So it's a little bit more advanced than a survey paper. It summarizes almost everything we talk in this class. Summarize all the vulnerabilities, how to defeat those attacks. Also, there's another paper, 2016, on state of the art of war, offensive techniques in battery analysis. So that paper is more about how do we automatically exploit those vulnerabilities. So we're not going to cover a lot of the content in that paper. Other papers, shining lights on shadow stack. Shadow stack is one of the techniques to defeat stack-based buffer overflow. So that paper talks about all the different types of shadow stacks. Also, there is another book I recommend you to get. Well, in our class, we do not really directly use this book, but if you are interested in this area, you want to go beyond what I teach in this class, that is a book you can go for. So that book covers battery, reverse engineering, covers symbolic execution, dynamic taint analysis. Those 10 years ago, those were 15 years ago, they were like very advanced topics. But right now, those techniques are very mature, used in all the research projects. Okay, so next I will show you the system we have been developing in our lab for this class. So this is the first semester we use this. So there may be some problems. If there are some problems, we do have the backup virtual machine ready. But hopefully we can just use the system. So this is the link to this system. Right now, this system is only available for you. If you want to access this, since you have to access anyway. So, so if you are off campus, you have to connect to the UB network using VPN first to connect to the system. And please register an account on the system. Please use your UB username and email address so the TA can easily identify who is who. Okay, so then I will give you a tour of the system. So I already have an account, so I will just log in here. You can just register here. So the system, there will be, there is a challenges tab. So every week we will upload new demos, new challenges here, including what I demonstrated in the class and also for the homework. Yeah, make it a reminder. So for example, this week I have several demos. and there is an add challenge. The points here doesn't really matter. So if you click this challenge, what you get is a page like this. Then you can run this challenge. So by clicking this run challenge, what happens is the server will create a Docker instance specifically for you. So you are not going to interfere with other classmates. And we don't necessarily need this practice challenge button, but it's there. Then you can also download the binary everything by click download. For example, if I click run the challenge, the first one, then the system will tell you you can SSH in. So you can control that Docker instance. To make it even more convenient for you, you do not need SSH in. You can directly on this browser, you can click terminal. Then you have this Docker instance running here. So if so you can see that this is the week 1 and program. So this is the challenge for that. So if we just you can just run this program and tells you this is a program to add 2 numbers together, just like that. So you can see under the hood, this is a Ubuntu machine, and when you log in, you are under the username CTF. You're not root. This program is actually a set UID program. This program's owner, as you can see, is root, but you are account CTF. So when you run this program runs as root. We'll talk about that in a minute. This week I have several challenges designed for you to get familiar with this system. This is where we're going to have all the demos, all the homework, and the exams. Okay, so there is also a backup virtual machine. I don't feel I will give this to you at this moment because hopefully we don't need this. We have been using this backup virtual machine for 2 years. So there are many tools you need to get familiar with. We can cover that later. Okay, so there will be a lot of readings in the class every week, probably like 1 hour reading. I also, for one of the classes, I think I even gave you guys a video. It's basically a keynote speech from a class. That's at the end of the class. That keynote speech is like 1.5 hours. It covers a lot of things we talk in this class. So after each Wednesday's class, I will send you a kind of like a Word document. That document lists all the homework, all the papers you should blog, you can read, you should read. There will be some assignments every week where you need to code and also hack. So those will be the same document. So for each homework, you have 1 week to finish. We'll have 14 homeworks in total. We have 15 weeks in total, I believe, but only 14 homeworks. So for each homework, you have 1 week to finish, which means you need to submit the homework before Wednesday's class. Because we may talk about the homework in the class, if you submit your homework through just UBNerds Blackboard. If you submit your homework 10 minutes after the class starts, you will get 30% penalty. After 10 minutes, you do not get any point. Okay, so this is very strict. So last semester, I believe maybe 40 or 50% students got A. Maybe if we count A minors, probably 60% or more. That's because this is how I designed the course. Every week there is homework. And if you finish your homework every week, you cannot fail the class in the first place. If you do kind of good in the exam, then you probably will get an A. Okay. So for those who last year only one guy didn't pass the class. He didn't, obviously, he didn't do all the homework. Right? Okay, so some of the homework may not be that easy. So if you receive the homework, you should just start early. Do not wait for the last minute. Obviously, plagiarism is a crime here. If we find out that plagiarism happens, then you get 0 points for your homework. There's no exceptions for that. Okay, hacking, there's a hacking assignment. Obviously, then there are rules. For each hacking assignment, you will submit your own exploit. You will submit a simple write-up to explain how you developed the exploit. You also will take screenshots on the system if you are using the cloud, or if you are using the virtual machine, take some screenshots to show you actually get it work. You will, so the write-up, you will briefly describe how you solve the challenge. If you worked with someone else in the challenge, then you can also mention their names. Okay, so you can work together as a group to finish the homework, but it's not okay. You can discuss, you can even discuss on Slack, but it's not okay to copy others' homework. And also, you cannot share your code, exploits, write-ups online. Because this is for future students. I also want to give them the experience you have here. Besides homework, there are 2 exams. One is midterm, one is final. For midterm, there is a written exam and also the CTF. For final, the same thing, but the final, the written exam will be a take-home exam, just several questions. The midterm CTF, I plan for 2 hours, will be Monday and Wednesday. The final CTF will be the final exam time decided by the department. It will be 3 hours, just the final CTF. So we're going to use the cloud system. It will be, usually it will be a lot of fun. Okay, the grading policy. So far, any questions? Okay, good. Grading policy, there will be, well, the total is 1,024 points, exactly 1K. 14 homework, each one 45 points. Sometimes I may give some bonus points. Usually it's because someone finds a bug in my challenge. Then I have no choice but to give you some bonus points to make the challenge work. Okay. The CTF, final CTF, 120 points, midterm CTF, 80 points. So those CTFs, those challenges are based on your homework. So if you fully understand your homework, you should be able to solve those challenges. Also, like I said, I expect everyone to be here in person, but it's not quite possible for this semester. So so if you are online, you also need to type your name in the chat box so I know you are here. I do not take check attendance every week. I just do that randomly. For the weeks I do not check attendance, then I just give out 3 points. Also, there will be 2 anonymous course evaluation during the semester, midterm and the final. So how that works is that evaluation is anonymous, obviously. So if 90% of this class submits the evaluation, 90% of the class, then everyone will get 10 points for bonus. So total is 20 points. So obviously, if the class is smaller, the chance you get the bonus point is higher, right? Last semester, 50 people, so they get both bonus points. So let's say if you guys can be light this semester. Okay. Last one, I need to emphasize academic integrity before we dive into hacking. Like I said, discussion is encouraged. Well, there's a typo. You should discuss with each other, but you cannot directly share your code, post it online. Also, you should get familiar with policies against academic dishonesty at the university, especially for students who just arrived at this country. So how many of you are new here? Just arrived? No? Why every question I ask, no one replies to it? Okay, that's good. So it means you already know something about the policy of the university. In short, I have zero tolerance towards academic dishonesty, plagiarism, or any form of cheating in homework, assignment, or exams. Is subject to very serious penalty. So any violation, I will report to the dean's office. So I think two students, 3 years ago, two students in a class, they had some serious issues and they got F in my class. So maybe the dean's office will give them, I don't know how to rate that, but the greater F, less than sign that. So maybe the dean's office will mark that in their final transcript. Guys, what are you talking about? Okay. Guys, do you have questions? Okay. Cool. Okay. So what I'm teaching in this class is hacking. So obviously we have to, don't violate any law, and also do not even attempt to do that. If you discovered some real-world vulnerability using the knowledge you learned from this class, you can report them responsibly and get some credits for that. You may have some CVEs, have your name with that. Some companies even give you cash reward for finding some vulnerabilities. So do not violate the law, which is very, very important. Okay, any questions before we move to the background knowledge? Okay, let's go ahead. First piece of background knowledge, I will talk about compiler, linker, and loaders. So let's take a look at how to compile C program into binary code, machine code, and run it on some operating system and also hardware. So C is a high-level programming language. Obviously, it is not as high level as some other languages you are familiar with, like Python or Java, but still, we consider it as a high-level programming language. Its source code is human readable, but it cannot directly on any machine. So we need a compiler to convert it into an executable code that consists of machine instructions. And obviously for different machines you run the code, the executable you got should have specific machine code. So in this class, we use Ubuntu Linux as your host operating system, mainly GCC in your as your compiler. In our research, we mainly use ARLVM, but for this class, we just use GCC. So there are 5 phases from a C program into a process running on an operating system. 4 of them are part of the compiling stage. We will first start with pre-processing. So you have the source code, which is human readable. Then part of the GCC, which is called CCP, you don't have to remember this. You just consider GCC will do the magic anyway. So we're pre-process for each save file. For example, there will be comments in the save file, they will be removed. There are macros, they will be expanded, including those included files. So maybe since you know C, you probably know that you can do some conditional compiling using directives like if define, if not define, those things. So those are just ask the compiler to do something in the pre-processing stage. The output of this step is still source code, and usually it's .i files. Well, but if you just use GCC to compile C file, you do not usually see that. Okay, so later I will show you, you can actually get those files. You can ask GCC to store those files in your local disk, so you can analyze them. So those .i files then will be go through the stage called compiling. From there, it will compile the C code into assembly code. Then you will use assembly, which is another compiler, to compile your assembly code to something we call object code, the .o files. So those object files, object code has machine instructions. So everything here, those first three steps, that's still text. Even the assembly code, that's still text. They're still human readable. So after this step, the object code, then those are binaries. Inside of that, those are machine instructions. Then we will use loaders, linkers to glue different binaries, object files together into one executable. Then when you want to run this program, the operating system will load that. So after you compile, it's basically a file executable in your local disk storage. Then the operating system needs to load that from your disk to your main memory, usually which is a DRAM, right? So how many of you developed a shell in the operating system class? How many of you took the operating system class? Okay, so usually so like 1/3. So usually the operating system class, the first assignment is develop your own shell, right? So your shell will kind of play the role of a loader. You will use several system calls to load different programs, like the exe, cve, those system calls. Yeah. So your shell is not really a loader. Your shell will trigger the loader to load a program. So when a program is loaded in the operating system in the DRAM, we call it a process. So it's not static anymore. It's actually a program running in the system. So during the process, there are a lot of metadata involved, include symbol tables, re-entry tables, library files, those things. So the loader, which is not really part of the OS kernel, but it's part of the C library in this case. It will take the following steps to execute a new program. It will first validate if the request to create this process is valid. For example, whether the user who is using the computer has a privilege or permission to run this program. Then it copies the program image from the disk into the main memory. It also sets up the stack for the process. Okay, that's a very important step. For any C programs, the stack has to be set up because any C function will use the stack. So we will see that next week. You can see the details. It will also copy the command line arguments onto the stack. So the program can access those command line arguments. For example, the code I showed you and two numbers together. Those two numbers are command line arguments. So think about what happens here. When I do this, so basically this is your shell program. This is your shell. In shell program, we can create other process, and this is a process I'm going to create from this binary executable. And when I created this process, too small. When I created this process, I want to give those command line arguments to this process. That's why the shell, the operating system, has to copy those two values to the address space of this program. Okay, we will see this later in the stack-based attack. We're going to exploit this feature basically. Then the loader will also initialize the CPU registers for the new process. For example, it will make the stack pointer to point to the right memory address. The last step, the loader will yield the control of the CPU to the new process, basically to the program entry point, so that process can execute its own code. Like I said, the loader is not really part of the OS kernel. On the system we are using, is actually a part of this library, node linux.so. And this library is not running inside the kernel. It's a userland program. We are not going to talk about the details on this one here. Next, I will show you our first demo of this class. In this class, we are going to say a lot of programs like this. They are very simple. This one, there is no. Oh, this one also has a more. Technically, there is a. That's on the phone. Later, we'll see a little bit more complicated programs, but usually, they're 39 of the code. So for you to easily understand this. For this program, I just want to show you how compiler works. We have a main function here, main function file here. So this main file includes several header files and also have a main function. The main function takes two arguments. So if you program your C, you already know that. This program always have a main function, and the main function takes two arguments, three arguments, or no arguments. In this case, if it takes two arguments, the first one is for argc, which count of the arguments. Means how many arguments we will have. In this case, the argc will be 2. So we promise that value will be 2. The argc is just a different strings you give to that program here. So as you can see, when I invoke the program, when I invoke the program like this, how many arguments are there? There are actually 3 arguments. This is the first one. So this is argv0, okay? And this one is the second one, and this is the third one. And when you invoke the program like this, those 2 arguments are not numbers. Okay, they're strings. That's why we need to convert them into integers in a program. That's why in this program, what we do is we get the value of argv1, which is the first argument, which is the second argument. We change it from a string ASCII to an integer. Change it to the second one again. H1 is not really standard for 3 function anymore. I have to do that. Don't just add them together. So when we add them together, we call the add function. The add function is another C file, which is very simple. We just add them together. I hope I'm fix here just to show you all macro works. if we compile this on Linux, use so at least the 2 commands here for you to use. This is what I will have in my slides this semester. It will have multiple templates that can use those commands to compile the programs. So we are still here. Make clean here. Oh, I don't have a make clean. Let's say it's too big. Oh, we put the source code in the folder. In this case, it's the end folder. See that? So if it's just a binary, for some of the challenges, we will only give you the binary. For some of the challenges, we will give you a source code. Let me explain a little bit about this thing here. So every time you create this Docker instance by clicking a challenge, it will generate a flag. Okay, this is a flag file, and this flag file has some randomly generated string. Everyone, when you log in a system, when you click that, you will have a different flag. That's how we know if you took someone else's flag, we know you are cheating. Okay, so here you log in as the user CTF, right? But the flag's owner is root. So you cannot directly read that flag. So if we do a cat flag, you cannot get anything. Permission denied. Okay. That's why for each challenge, usually there is a binary like this. But this one is not available. This binary is a set UID program. That's why you can see it has a red background, which means it's a set UID program, which means when it runs as a root. Okay, you can see the only root. When I log in, I'm CTF, I'm not root. But when I run it, the program runs root. So as a root, the program will be able to read the flag, right? So but the program will not directly read the flag. It's your job to somehow tweak the program to read the flag and print out that to you. Okay. We have another example here. Oops. One of the challenges we have here is called a read secret. I click run challenge. Then when this pops up, means the system is ready. Then you go to the terminal. You can see all the files here. You can say this read secret file program belongs to root, and it's read, so you read UID program. If I do a cat flag, I will not be able to get anything. But if I run that program, let me show you the source code of our program. Okay. So this is a source code of the program. Can people in the back see it? Okay, a little bit bigger. Okay, so this is a set UID program. What it does is basically it gets the current real user ID and effective user ID, then print that out. After that, it will just call the function print flag. Okay, the print flag function doesn't do anything special. It will just open that flag file and print it out. It's actually under where is that? The library somewhere. So everything here is basically the code I developed for this class. Okay, I cannot find that file right now. Anyway, it's just read a file. So if we go back here, we run the read We run with the read secret program. Hold on. What's going on? Oh, yeah, it's called, sorry. It's called week 1 read secret. So you can see that when I run this program, read secret, it will print out. You will print out the flag for you. The flag is dynamically generated. We create that other feature. So go back to that and program. So if you want to go back to another challenge, you just click here, then click that challenge, click this. Then when this pops up, that's ready. So this is here. We go to and. So you can see those are the 3 programs I showed you. What we can do is we can compile it using this command. So what's special here is I gave GCC instruction to save all the 10 files, okay? And I told GCC to compile this into a 32-bit version of the program. So when we do this, we will get a lot of 10 files. The .i files, the .s files, the .o files we just talked about, okay? So if you do not give save temps, GCC will not save those files. So for example, we have this and .c file. This is a source code. We are adding 2 numbers together and also add a 50. So let's say the corresponding .i file. Remember, what is .i file? .i is after pre-processing, right? So if you look at the source code here, there is a macro. So that pre-processing will expand as a micro. It will not be that anymore. You can see that base is not there anymore. It's replaced by 50. Okay, that's what the preprocessor did. Then after that, we have .s. Then we can say there is a and.x. Then this is the assembly file. Okay. Then starting from here. Okay. Then after that, we will have .o. And like I said, .o is not text anymore. If you do a cat, you just get a this kind of a garbage because they are binary. So that's why you need to use other tools to read it. So in this class, there are a lot of tools, fancy tools we can use, but in this class, we try to use simple tools. We just use object dump. You do object dump, you do a -d means disassemble this. Then you do and.o. Then you can disassemble the program. And you can say very simple program. You only have 5 instructions. That's the program. So you go back to your C code. Your C code is also very simple, just several instructions. Your C code is just 1 line of code. And when we change it to, when we compare this into binary, it's only 5 instructions. Okay, you can try to understand what's going on with this. We're spend some time to understand what's going on here. You don't have to fully understand everything here today, but we can. So the first instruction, let's see what we can ignore this for now. The second instruction is to move EAX. Move what is EBP class 8. So EBP is a set pointer. The set pointer points to the memory. To move that what the set pointer points to, and 8 bytes higher than that, to the general register ABX. then add what the EPS points to higher than 4 by exact with the EX. So the EX value has been changed. Then we add another 32 in text, which is 50 to this register. Then we just return. This one. So actually we're going to talk about that in the next class. And extend it here. So what you are saying here is something called a assembly or assembly, right? Find the detail syntax, find the ATM syntax. You can choose whatever you like. Some people hate ATM syntax. I don't really hate that. So what this instruction means, we are going to add the value taken from this memory address. This one is a memory location. Taken from this memory location and what is already in the general register EX, then the result is always here in the EX. That's basically what it does. So you can say that we have in this function we have int A, we have int B. Those are two parameters. But obviously they are at those two locations. Plus 8 and plus 4. Yes, yeah. Then we have the base another base value. So after that, we will link everything together as an executable, which is this ADD file. So what we can do is this file. So you can use a file command to do a add.o. The file command tell you what this file is. Like I said, this is an object file, right? Object file is also L file, which we will talk about in the second week. So you can see here, we do a file on this one. It says this is an L file. This is a 32-bit relocatable L file. And it's not strict, means there are symbols there. If we do the same thing on the battery file, the executable, it will tell you this is a 32-bit ELF battery file, which you can run technically. So if you do this program runs like this. Okay, so that is our first demo in this class. Oh, we can also compile this into a 64-bit version. Let's compare the results. You can see the commands I'm using here, they are almost the same. The only difference is this -m32. When I use -m32 means I want to compile this into a 32-bit version. Otherwise, the default is 64-bit. So when I compile this into 64-bit, we got the 64-bit code. If we do a file on this, you can say file says this is a 34-bit ELF, and this one is a 32-bit ELF. And if you do a disassemble on them, you can also tell the difference. We do a obj dump d and 64. So this is the add function in the 64-bit version. Remember the previous one? Well, we have 5 instructions. 64-bit version we only have actually 3 instructions. This one doesn't really count. This one is not really instruction because here we already returned, right? So this one is just because the results is a similar way using single instruction, but the program already solved it. So the real instruction is just one instruction. This instruction can add those 3 values together in one instruction. And you can see the registers are different as well. Okay, so I know it's very difficult to understand right now. That's why in the next class and next week, we're talking about all the details. We'll start with the x86 architecture. We will talk about all the registers. So you will get familiar with those names. You already say ESP, RDI, those look super weird, but after this, you will know what they are. After that, we will look at the syntax of those instructions. So we will talk about this. What is the meaning of those? Then we will talk about different instructions: jump, compare, call, return. After that, we'll talk. This is a 64-bit version. We will see. We already look at this. Actually, yeah. Then we talk about Linux file permissions. What are set UID programs? The read secret code. We will take a look at that again. Then next week we will talk about what are L files. That is one of the very important things related to what we're teaching in this class. We talk about the memory map of Linux and what are system calls. So the first 2 weeks were just building a background. The third week we started to doing hacking. The first hacking will be a stack-based buffer flow, and we will spend a lot of time on that one. Because at the beginning, this class is very challenging, but after midterm, you will be much more familiar with all the assemblies since we're getting easier. So the second half of the semester, we will move a little bit faster. We will talk about more advanced topics in the second semester. Second half. Okay. For example, what I do is I will give you instructions like this. Then we will clearly say how everything works. One instruction by one instruction, so you can fully understand what's going on. Okay, I guess that's all for today. No homework today, but there will be homework after Wednesday. Any questions? For those who are on Zoom, could you please type your name? So how many of you are still here? I see. Okay, very good. I hope I can see you guys in person next week if there are no other good reasons. Okay, that's it for today. Thank you, guys. Yeah, give me 1 minute.